Hello everyone. On this video we will be looking at just a few basic fraction story problems. And again, remember that you have almost an infinite number of problems that you could see using basic fraction. These are just a handful to give you an idea of how you could possibly approach them. So by all means, like I said before, if you have a method that works for you that's different from mine, by all means, feel free to use that one. I want you to do whatever method works best for you. Okay, so starting off, we have this problem. So let's say we have an electrical light circuit in John's welding shop had a load of 2,800 watts. He changed, that should be, there we go. He changed the circuit to 10 150 watt bulbs and 6 100 watt bulbs. What fraction represents a comparison of the new load and the old load? Alright, so what I want you to do is go ahead and press pause and finish writing that down if you have to. But I want you to go ahead and try to solve it on your own. Just give it a shot. Alright, so I'm assuming you've pressed pause and you've worked it out. And let's go ahead and verify your answer. Okay, so the first thing you want to do when dealing with your story problems is write down what's given to you. Okay, so what's given to us is the old load is 2,800 watts. And the new load, this is where it gets a little bit tricky. Okay, so you have 10 150 watt bulbs and 6 100 watt bulbs. Okay, so you have 10 150 watt bulbs and 6 100 watt bulbs. So that means your new load, 10 times 150, is 1,500, plus 6 times 100 is 600. So that new load is going to be 2,100. Okay, now your second step is you're going to now ask yourself, what do they want me to solve? What am I solving for? Okay, so what you're solving for is you want to find the fraction that compares the new load with the old load. Okay, so find fraction comparing new load with the old load. Okay, so we have our new load and our old load. Okay, so our new load is 2,100. We figured that out right there. And our old load, 2,800. Okay, now we can actually simplify that because 2,100 is 3 times 700, and 2,800 is 4 times 700. Okay, so anything divided by itself, these two cancel out and it becomes just 1. So you end up with 3/4. Okay, so that's the fraction that represents the comparison between the new load and the old load. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. All right, so for this one, you have a machinist who had been producing 40 parts per day, increased the output to 60 parts per day by going to a faster machine. How much faster is the new machine? And you want to express your answer as a mixed number. All right, so go ahead and pause this if you have to pause to finish writing, and go ahead and try to solve this one on your own. All right, so I'm assuming you're all done solving this one, and you paused it and got all that stuff done. So let's go ahead and verify your answer. Okay, so remember the first thing you want to do is see what's given to you. All right, so we know that our new machine gave us 60 parts per day. Okay, and our old machine gave us 40 parts per day. Okay, so that's what was given to us. Okay, so now, second, what do they want us to solve for? Well, just like the previous example, they want us to compare the new and the old machine speed. Okay, so if we do that, we know that our new compared to our new machine speed is 60 parts per day, and our old machine speed is 40 parts per day. Okay, so now you know that 60, we can rewrite that as 6 times 10. And 40, we can rewrite that as 4 times 10. These two cancel out, so you're left with 6 over 4. All right, so now actually, I could have simplified it a little bit more here, but I did this on purpose. Because sometimes when you simplify, you don't always simplify all the way on the first step. Here, we simplified it and got it down to a nice small number, but we can actually simplify this even more. Okay, so 6 over 4, remember 6 is 2 times 3. And 4 is 2 times 2. So anything divided by itself, those cancel out and you get 1. So you end up with 3 over 2. Okay, so actually what I could have done right at the very beginning is made 60 equal 20 times 3 and 40 equals 20 times 2. So I could have done it here and got that same answer, but I wanted to show you that sometimes you can simplify it more than once. Okay, so here we have how we can look at our new machine speed compared to our old machine speed, but this is an improper fraction, and they want us to express it as a mixed number. So, let me write improper fraction. So we have our 3/2. So remember, 3 divided by 2, we just rewrite that as 3 divided by 2. And we divide. 2 goes into 3 one time. 2 times 1 is 2. 3 minus 2 is 1. Okay, so that's our whole number, or our quotient. Our remainder is our new numerator. Our denominator stays the same. So you end up with 1 and 1/2. Okay, so this means that the new machine is 1.5 times faster than the old machine. Oh, move that up a little. There we go. All right. So if you are still writing, by all means, feel free to press pause. But we're going to go ahead and go to our last example. Okay, so for this example, a ridge beam rises 18 inches over a horizontal run of 72 inches. Calculate the pitch of the roof and express it as a fraction with a denominator of 12. All right, so note, when you have a roof pitch, it's the rise over run. So your pitch is equal to rise over run. All right, so what I want you to do is go ahead and press pause. And after you're done writing this down, I want you to try and solve this one on your own. All right, so I'm assuming you have pressed pause and you have solved this problem. So let's go ahead and verify your answer. Okay, so remember your first step. See what's given to you. Okay, so what they gave you your vertical rise, which is 18 inches. And they also gave you your horizontal run, which is 72 inches. Okay, so that's what was given to you so far. And we also know that the pitch is equal to our rise over run. Okay, now, second step is, what are they asking for? Okay, they want us to find the pitch. And express our answer as a fraction with a denominator of 12. All right, so we know that our pitch is equal to our rise over run. All right, so our rise is 18 inches and our run is 72 inches. All right, so if we go ahead and simplify this, we know that 18 is 9 times 2. And we know that 72 is 9 times 8. Those two cancel out. 9 divided by 9 is 1. So you end up with 2 over 8. Now, Once again, like we did before, sometimes you don't get it all in the first simplify. So 2 is 2 times 1, and 8 is 4 times 2, or 2 times 4. 2 divided by 2 is 1, so that cancels out, so that leaves us with 1/4, and that can't be simplified anymore, so we know that's our answer. Well, almost our answer, because remember, they want it expressed with a denominator of 12. So that means our 1/4, we have to turn that into something over 12. Okay, so 1/4 equals what over 12? Okay, so we know that 4 times what will give us 12? Well, 4 times 3. So that means our 1/4 equals something over 12. We have to multiply that 4. Let me give that a little more room. We have to multiply that 4 by 3. And anything you do to the denominator, you have to do it to the numerator. Okay, so you have 3 times 1, which is 3, over 3 times 4, which is 12. So the only way this will be be true is if your unknown is equal to 3. Okay, so we know that we have to rewrite this 1/4 is equal to 3 over 12. Which is how we will write our final answer. So even though this 1/4 is correct, because they said they wanted the answer written with a denominator of 12, if you wrote 1/4, you are almost correct, even though the answer was right, but it wasn't in the right form. So you have to make sure you're careful for those little details that they ask for. Okay, so even though, like I said, it's correct, you want to get full credit for any work, all the work you did. You want to make sure you get all of your credit. So you don't want to leave it right here when that last little step is still there. All right, so hopefully this made sense, and I will see you on the next video.